Hey students, so today we shall be just taking a step forward in that capacitance chapter. So it's nice to be in front of you. So let's just start. So today we shall be learning about how to find the capacitance. How to find the capacitance. Okay, we are going to find the capacitance of a capacitor, of a parallel plate capacitor, of a parallel plate capacitor with a medium in between the plates. In between the plates. I'm a little bit sick due to this changing season. So, is this visible to you? क्या आपको ये दिख रहा है अच्छे से? हाँ, दिख रहा है. So, let's just continue with that. Okay, तो हमें क्या निकालना है? किसी कैपेसिटर का, किसी पैरेलल प्लेट कैपेसिटर का हमें निकालना है कैपेसिटेंस, उसका कैपेसिटी निकालना है. अगर हम दोनों प्लेट्स के बीच एक मीडियम रख देते हैं तो उसका कैपेसिटी कैसे अफेक्ट होता है. ओके, सो उसको समझने से पहले हमें थोड़ा रिकैपिचुलेशन करना पड़ेगा. वी नीड टू रिकैप समथिंग. ओके, सो इफ इट इज अ कैपेसिटर, so let P be a plate and Q be another plate, and this is earth connected. This is earth connected. So the capacitance of this parallel plate system is given by C equal to, C equal to epsilon naught A by D, when air is the dielectric in this medium. Okay, or air is the medium between those two plates. Since we have air as a medium, so let's just name it 0. C naught or C0 is epsilon 0 A by D, or epsilon naught A by D, whereas A is the area of the plates and D is the distance of separation of those plates. Okay, so this is the capacitance of this parallel plate capacitor when air serves as the medium between those two plates. Okay, so इसका कैपेसिटेंस ये है जब इसके बीच का जो मीडियम है एयर से फिल्ड है और वैक्यूम से फिल्ड है. सो ना आपको कैपेसिटेंस मिल गया, आपको अभी निकालना है उसका पोटेंशियल. उसका पोटेंशियल लेट ई बी द इलेक्ट्रिक फील्ड. अगर इसके अंदर का फील्ड अगर ई है और समझ लो कि एयर के वजह से वो ई नॉट है. ओके, सो ई नॉट इज द इलेक्ट्रिक फील्ड, d is the distance, then potential difference, let that potential difference be v naught. Okay, potential difference is equal to v naught. So what is the potential difference between those two plates? It is v naught. So v naught is equal to e naught into d. V naught is equal to e naught into d. As we know that electric field is the gradient of potential, is the negative gradient of potential. But keeping in view of those conditions, and the negative sign or cancel out by another negative sign that is involved. We have done that before, I am not showing it now. Okay, so the potential difference between those two plates is V naught is equal to E naught into D, where D is the separation. Okay, so up to this point I think you have understood it. Now what we shall be doing, we need to introduce. Okay, but before that let us just find out the formula for electric field. So what is your E naught for a parallel plate? For the inside of the P naught is sigma by epsilon naught. It's sigma by epsilon naught, or as sigma is the surface charge density, if Q is the charge, then Q by epsilon naught A. This is the value of your electric field. ये electric field का value है इसके अंदर. Okay. So this much of things we need. Now we need to introduce a conductor. First of all, it is our special case first. Case first. We introduce a conductor is introduced. Okay, a conductor is introduced. Conductor is introduced. Just follow me. You will understand it. A conductor is introduced. Its thickness. What should be the thickness of that conductor? Its thickness be T. Okay. Its thickness is equal to T. So this is what we shall be doing afterwards. This is your recapitulation, or this is the most required information before deriving the cases. Okay. So as you know, the capacitance of the parallel plate capacitor in presence of air as a medium inside those two plates, it is C naught equal to epsilon naught A by D. And you are very familiar with these terms. It is the permittivity of vacuum. It is area of those plates. D is the distance of separation between those two plates. If V naught is the potential difference between those two plates, then it is equal to E naught D. Whereas E naught is the electric field between those two plates, and we have derived the we actually know the value of electric field. Is it continuing? Yes, it is continuing. So it is sigma by epsilon naught, and sigma is charge per unit area. So charge is Q, the area is A. So in place of sigma, we introduce Q by A. So the formula is like this. I hope that you have understood up to this point. Okay, now let us continue from this. Just draw another capacitor. It is going to take less time. So that's the same capacitor. So we haven't even written some statements. Okay, we don't require it right now. But before that, we can add some statements. It will be easy for you to remember it in the exam or write in the exam. So let me just rub this thing off, and I am adding some statements. Okay. Don't worry, it won't take much time. Let P and Q be the two plates of a parallel plate capacitor. Okay, I think you can write it. Okay, A is the area of each plate, or is the common area of each plate, and D is the distance, is the separating distance, separation. Okay, separation distance, you can actually continue like that. Let air is inside the plates. Since air is inside those plates, the capacitance C naught is equal to epsilon naught A upon D. Okay, up to this point you can actually follow the formula. Now the potential difference B V naught, we have actually calculated all of these things. हमने ये पहले कैलकुलेट करके रखा हुआ है इसके प्रीवियस लेक्चर्स में, उससे आप रेफरेंस ले सकते हैं, लेकिन अभी हम इसको पूरा डिराइव नहीं करेंगे because it will take a lot of time. So potential difference between those two plates is V naught is equal to E naught D. Okay, everything we are writing as naught. Okay, we are adding a naught to every term because air is inside, or air is serving as the medium inside those two plates. Okay, So if we doing anything except air, then we shall be writing some other, like we be giving some superscript or subscript. Okay, don't worry about that. And electric field. What is the value of electric field? E naught is equal to epsilon naught, or sorry, sigma by epsilon naught and q by epsilon naught, which is equal to this thing. Okay, this is the much needed information we needed to put before starting this concept. Okay, now what is the case that we are introducing a conductor inside of that parallel plate capacitor system, and the thickness is T, and the thickness is T. If this is a conductor, okay, this is a conductor, this is a conductor, and its thickness is T. Okay, I think it is visible to you. Its thickness is T. So let me just take it down a bit. So its thickness is T, and the total distance of separation is D. This is our conductor, and the area remaining is air, and the area remaining is air. Okay, and you have known from the previous lectures that the electric field inside the conductor is zero. You know it very good. Okay, so what is the first case? A conductor is introduced, a conductor of thickness T, you can write it like this, a conductor of thickness T is placed inside. Okay, if conductor is filling the teeth distance, then the remaining distance or the remaining portion is filled by air. Okay, and the electric field inside the conductor is zero. So up to this point, I think you have understood it very well. Okay, so we shall be continuing. So let me check again if it is visible or not. Yes, it is visible. So without any air, the potential difference between those two plates was V naught. Okay, without any, oh sorry, with the application of air as the medium, we had the potential V naught equal to E naught D. Now that, so we can actually see that the potential is directly proportional to the distance of separation. Okay, now we have added a conductor of thickness T inside those two parallel plates. Okay, so the remaining things, so here inside the electric field is zero. I can actually write it out like this: electric field is zero, but electric field at this portion and in this portion are not zero. Okay, so if, and the same electric field, okay, since this is air, the same electric field, it is E naught. Since it is positively charged, it is negatively charged, this electric field is E naught. Okay, so if V be the potential difference between the plates, let V be the potential difference, the potential difference. So what should we write? V is equal to place E naught, and since here the separation distance was D, but here we have electric field in these portions. Okay, in this portion is T, so the remaining portion is D minus T. Okay, the remaining portion is D minus T. So you can actually write it here, D minus T. Now we have to fill in the formula for E naught. So V is equal to Q by epsilon naught A D minus T. This is the required formula. Okay, this is the required formula. We do not need the above things anymore. If I can continue. So let me continue at this space. I have to remove these things. We remember these things. Okay. So we know the capacitance of this system Vicky. Let C be the capacitance. With air it was C naught. Okay, So we are doing just like C. So C is equal to Q by V, as we know from the formula. So Q, now put the value of V, Q by epsilon naught A D minus T. So this Q and Q gets cancelled out. So C is equal to epsilon naught A by D minus T. This is the value of the capacitance of the parallel plate capacitor when a conductor of thickness T is introduced between those two plates. Okay, so you can actually see the capacitance depends upon D minus T. Okay, that is inversely proportional to the distance of separation. Now, a special case of a special case. It is our special case. Now we are going to do a special case for a special case. So let me just do it a bit longer. So now, if I feel the total portion by the conductor, I feel the total portion by the conductor. That means T is equal to D. If the total space, is filled, so you can actually see that C is inversely proportional to D minus T. That means let me just conclude something before I am going to this point. Previously, what was your C naught? I am going to rub this up here with air. It was epsilon naught A by D. It was your previous formula. Okay. Now, when you added a conductor inside those parallel plate capacitor system, you can see that the denominator has decreased. You can see that the denominator has decreased. Denominator कम हो गया है. That means capacitance बढ़ गया है. If the denominator of a fraction decreases, then the value of that fraction increases. So ये आप देख सकते हैं, अगर हम कोई कंडक्टर ऐड करते हैं as a medium inside the plates of a parallel plate capacitor, you can actually see that the capacitance of the system has already risen. So the capacitance has increased. So आपको अगर किसी भी कैपेसिटर का capacitance increase करना है, then you have to add a conductor. Okay, you have to add a conductor inside those two plates. So आप देख सकते हैं, it is evident to you that epsilon naught A by D minus T is always greater than epsilon A by D. Okay, so leave this thing. So इसको conclusion में लेते हैं. It is your answer, and you can actually see capacitance has increased. Capacitance has increased. ये तो evident ही है आपको. Okay, has increased. Now, if the total space is filled with conductor, हमने क्या किया? हमने कंडक्टर से पूरा स्पेस ही फिल कर दिया. दैट मीन्स इसका मीनिंग क्या है? T इज इक्वल टू डी. ओके, T इज इक्वल टू डी. यहीं से कंटिन्यू करते हैं. अगर आपने पूरा स्पेस कंडक्टर से भर दिया तो आपका फॉर्मूला क्या हो जाएगा? सो एज वी नो आप यहां से कैलकुलेट कर सकते हैं डायरेक्टली. C is equal to epsilon naught A by D minus T. So what is your T? Epsilon naught A by D minus D. The value of T is D. That means epsilon naught A by 0, D minus T is 0. So your capacitance becomes infinite. Infinite capacitance. It can store infinite amount of charge. So in this condition, you can actually say that this capacitor, when filled the total portion with a conductor, can store an infinite amount of charge because the capacitance has become infinite. Okay, something by 0 is infinite. So we have finished the first special case. Now we shall be going to the second special case. Okay, so in the second special case, we shall be introducing a dielectric. Okay, we shall be introducing a dielectric between those two plates. Okay, so let me just rub these things off. So I am extremely sorry. uh, Power is off. Okay, you're facing power cutoff. So capacitance of a parallel plate capacitor with a medium between the plates. Okay, we have already completed the first part, the special part 1. Now we shall be going to special part 2. So हम second special part करेंगे. So what is that special part? So case 2. Okay, case 2. Case 2 क्या होगा? A dielectric. A dielectric, that means an insulator. A dielectric is placed. हमने तो इसका थिकनेस मेंशन नहीं किया. डाइलेक्ट्रिक ऑफ थिकनेस, a dielectric of thickness T is placed. Okay, उन दोनों प्लेट्स के बीच में हमने एक डाइलेक्ट्रिक रख लिया. उन दोनों प्लेट्स के बीच में हमने एक डाइलेक्ट्रिक रख दिया. ओके, सो जस्ट ड्रॉ ए कैपेसिटर. मैंने आपको पहले से ही समझा दिया था. अगर एयर होगा मीडियम तो उसका कैपेसिटेंस क्या होगा, उसका पोटेंशियल डिफरेंस क्या होगा और उसका इलेक्ट्रिक फील्ड क्या होगा. तो हमने क्या किया, हमने इंट्रोड्यूस किया एक डाइलेक्ट्रिक. थोड़ा बड़ा कीजिएगा क्योंकि हमें लिखना भी है. सो इसका प्लेट सेपरेशन कितना था, d. ओके, द सेपरेशन डिस्टेंस वाज d एंड द थिकनेस ऑफ द डाइलेक्ट्रिक इज t. डाइलेक्ट्रिक का थिकनेस होता है t. दैट मींस द रिमेनिंग पोर्शन इज d minus t. रिमेनिंग पोर्शन, आई एम एडिंग इट हियर. रिमेनिंग portion is equal to d minus t. This is your remaining portion. I think it is visible to you. Okay, that means ये एयर है, ये भी एयर है, लेकिन ये डाइलेक्ट्रिक है. सो इलेक्ट्रिक फील्ड यहां होगा E0, यहां होगा E0. लेकिन हमने पहले से पढ़ रखा है कि अगर ये डाइलेक्ट्रिक है तो इसके अंदर जो इलेक्ट्रिक फील्ड होगा वो E होगा. इन दोनों से डिफरेंट होगा और इन दोनों से छोटा होगा. इट इज रिड्यूस्ड. ओके, इलेक्ट्रिक फील्ड इनसाइड द डाइलेक्ट्रिक इज रिड्यूस्ड. ओके, सो चलो इसको स्टेटमेंट में लिखते हैं. वी हैव इंट्रोड्यूस्ड, वी हैव प्लेस्ड अ डाइलेक्ट्रिक of thickness T, which means we have air occupying d minus t portion. Okay, so yes, this power is back on. So field in air. So air portion में एक फील्ड होगा और डाइलेक्ट्रिक के अंदर एक फील्ड होगा. So field in air portion is E0, which is reduced. फील्ड के एयर के अंदर जो फील्ड है वो E0 है और E0 है, लेकिन वो डाइलेक्ट्रिक के अंदर रिड्यूस होके E हो गया है, which is reduced to E inside the dielectric. ओके, अगर फील्ड रिड्यूस्ड हो रहा है और यू हैव डिफरेंट फील्ड्स, सो पोटेंशियल क्या होता था, एयर जब होता था वो V0 होता था, लेकिन अभी हमने डाइलेक्ट्रिक ऐड कर दिया है तो आपका पोटेंशियल अभी हो जाता है V. ओके, ड्यू टू दिस थिंग्स आपका पोटेंशियल हो जाता है अभी. सो हमने तो फॉर्मूला पढ़ रखा था V0 इक्वल टू E0 इंटू D. ओके, दैट मीन्स V0 इज द प्रोडक्ट ऑफ इलेक्ट्रिक फील्ड एंड द रेस्पेक्टिव डिस्टेंस. सो हमने यहाँ का इलेक्ट्रिक पोटेंशियल निकालना है और पोटेंशियल डिफरेंस निकालना है कहाँ का, P और Q के बीच का. सो योर पोटेंशियल डिफरेंस विल बी potential difference should be V is equal to, what should be your potential difference? So you can see that E naught, the electric field E naught is extended to only d minus t portion. So you can write like this, E naught into d minus t, and an electric field is remaining inside this portion. So it is E into t. Okay, it is E into t. So आपने क्या लिखा, V is equal to E naught multiplied d minus t and Et. ओके, आपको ये समझ में आ चुका होगा. Now we are going to find out the relation between E naught and E. We are going to find out the relation between E naught and E. ओके, और हमने क्या निकालना है, हमने रिलेटिव परमिटिविटी को यूज करके हमें ये निकालना है इसका रिलेशन. सो आई थिंक इट इज विजिबल टू यू. ऑटो फोकसिंग. सो अगर डाइलेक्ट्रिक का रिलेटिव परमिटिविटी एप्सिलॉन आर है, इफ डाइलेक्ट्रिक हैज or relative permittivity, okay, relative permittivity epsilon r, then epsilon r is equal to E naught by E. epsilon r is equal to E naught by E. हमें निकालना है इसका वैल्यू. सो इस इक्वेशन से हम E का वैल्यू निकाल सकते हैं, E naught by epsilon r. Now replace this thing, the E thing, in that equation. Let's name it equation 1. So let me continue here. Replacing E in equation 1. हमने क्या किया, इक्वेशन 1 में E को रिप्लेस कर लिया. So what is your V then? V is equal to E naught d minus t plus, in place of E you need to put this thing here. So E naught by epsilon r into t. Is it visible? Yes, it is visible. So now आपको क्या करना है, आपको इलेक्ट्रिक फील्ड को कॉमन लेना है. ओके, इलेक्ट्रिक फील्ड को कॉमन लेना है. You have to take electric field common. So it is d minus t plus t by epsilon r. Okay, this is the value of electric potential difference between those two plates. So आपने ये कर लिया. So आप इसको equation 2 भी दे सकते हैं, ये modified है. Okay, now you have to find out the capacitance. Okay, now no, we are not finished yet. I just forgot. You have to put the value of E naught. You have to put the value of E naught. As you know, the value of E naught. What is the value of E naught? From the previous section, E naught is equal to sigma by epsilon naught, or Q by epsilon naught. You have to put this thing in place of this thing. Okay. So your V becomes epsilon E naught is Q by epsilon naught A and the other things, d minus t plus t by epsilon naught. So we have found out, we have actually calculated the value of V. Okay, now we have to find out the capacitance of the system. We have to find out the capacitance of the system. So it is an important equation. So if C equal to capacitance, then C is equal to Q upon V. Okay, C equal to Q upon. So calculate it. So just in place of V, just place these things, epsilon naught A d minus t plus t by epsilon r. Okay. So up to this thing, up to this step, everything is visible. Okay. So let me just take out another portion. We can continue on this portion. Okay. In this black portion, you have to adjust these things. Okay, we are almost finished. So this Q gets cancelled with the Q on the numerator. So आपका C क्या हो जाता है, epsilon naught A by d minus t plus t by epsilon r, ये होगा कैपेसिटेंस, ये होगा आपका आंसर. दिस इज अ रिक्वायर्ड आंसर. If you place a dielectric of thickness T inside the parallel plate capacitor and you know the relative permittivity of that dielectric, you can actually calculate the capacitance of that system. Okay. Now, if a lot of dielectrics are placed, the special case of this, as we did a special case in case 1, also we are going to do a special case in case 2. Okay. So just come to this point. We do not require butterfingers. We are done with the formula, so we are continuing a bit more. We are not requiring any of these statements more. Okay, so I am just writing the formula. C equal to epsilon naught A by d minus t plus t by epsilon r. Okay, the formula is like this. So we have introduced only one dielectric, okay, of thickness T. Now if we introduce a lot of dielectrics like this is your plate capacitor system, parallel plate capacitor system, and we have a lot of dielectrics like this. We have a lot of dielectrics like this, many dielectrics. Okay, so the thickness of the first dielectric is T1, it is T2, it is T3, and like that. And the relative permittivity of this dielectric is epsilon R1, epsilon R2, epsilon R3, and it goes like this. And d be the distance of separation. Okay, the d be the distance of separation. You have to add these terms. So the numerator stays the same, d minus, you have to add the thickness T1 plus T2 plus T3, which goes on, plus T1 by epsilon R1 plus T2 by epsilon R2. You have to add things like this. Okay, so here today's lecture is complete. You have to remember this formula. It is important. This is an important formula. You have to remember this. And this is just a continuation of this formula. The main formula is this. If you have more dielectrics and you know the thickness of those dielectrics and the relative permittivity of those dielectrics, so you can actually calculate the formula for, or you can actually calculate the capacitance of the parallel plate capacitor system. So up to this point, if there is any doubts, you can ask me through comments. मैंने तो कॉन्टैक्ट डिटेल्स भी दे रखे हैं डिस्क्रिप्शन बॉक्स में. सो आपको अगर प्रॉब्लम आता है किसी न्यूमेरिकल के बारे में तो आप पूछ सकते हैं. अगर किसी कॉन्सेप्ट के बारे में भी आपको पूछना है तो पूछ सकते हैं. इफ यू हैव एनी डाउट्स यू कैन जस्ट पुट अ क्वेरी in the comments, or I have provided the contact details, my contact details. You can actually contact me there regarding any numericals. So आप प्रैक्टिस करते रहिए. बोर्ड्स भी कुछ ही दिनों में आ जाएंगे. सो ये बोर्ड्स के लिए भी तैयारी हो रही है, और मेडिकल इंजीनियरिंग +2 के बाद जो एंट्रेंसेस होते हैं उसके लिए भी तैयारी हो रही है. हम कॉन्सेप्ट में जाएंगे. सो अप अंटिल देन टेक केयर. So see you. Thank you.